Well, let me go ahead and start off and tell you a little bit about myself. Brant, thank you for the introduction. I've been working in stormwater and particularly with LID for going on 20 years now. When I was working in Baltimore, we did a whole series of pilot projects where we would build like 6 different LID devices and monitor them and sample them and test them over time. We'll talk a little bit more about some of that later. I also spent 4 years running EA's construction management group. So I've been involved in construction management, and I think we're going to try and talk a little bit about the specifics of low impact development features and how maybe construction management is a little different than what you do every day. Have a quick agenda for you here. We'll talk a little bit about what is LID, why is it important to this group. A little bit on design and sort of, I'll call it the pre-inspection portion, because I think there's some stuff that as inspectors you might need to know about. And then the heart of the presentation will definitely be LID construction inspection. And then a little bit after that and some ideas to take home and thoughts for the future. What is LID? It's called a lot of things, a lot of places. And it seems about every 3 years they change the name because I think they can sell new materials. But low impact development, green stormwater infrastructure, green infrastructure. Environmental site design is a little different, typically applied to land development, like subdivision development, where you would, we typically talk about, thumbprinting, trying to go into a site and disturb the minimum amount of area possible. And so it's sort of looking at your whole site from an environmental perspective, although it can be applied to larger projects. And I'm going to focus probably more today on how this applies to linear projects like road and highway projects. One of many definitions out there, a comprehensive land planning and engineering design approach with the goal of maintaining and enhancing preconditioned hydrology. A lot of fancy words. I like this as a little bit simpler, seeking to control stormwater at its source. The real key to LID is we have traditionally piped all the water to the end of the pipe, and then when we realized that the water coming out of the pipe was dirty, we tried to do something down there to treat it. And with LID, we're always looking to go upstream and manage smaller treatment areas and manage the water on site, try and infiltrate as much as we can, keep the water where it started from rather than where it ended up. A couple of graphics of this here. You can see the one to the top and the left in pre-development. I guess the real take home on this is probably there's almost no surface flow going into the lake. And on this one we see, what do they say, 30% of our surface runoff is going because of the impervious area that we build. So our goal was to figure out how do we capture this water up here and try and do something with it here before it runs down the hill and we have all of the related infrastructure to pipe it, transport it, and then try and do something with it at the end. Just a list of some of the types of features that you may come across, and there's a lot of overlap in some of these names, whether it's a bioswale or bioretention or a rain garden, and these can all be various versions of the same thing. But generally, the difference here as compared to our traditional stormwater treatment is we're looking at not only infiltration, but even if we're not infiltrating a significant quantity of water, some sort of biological activity, using a soil mix with plants in it as part of our filter media for stormwater. And this is where the construction inspection, or really the whole process from design and construction inspection is a little different than what we typically do on, say, a highway project, because we start incorporating landscape architects into our design process and soil scientists. And, where this picture here on the top is a Filterra tree box. They have a patented soil mix they put in there. So they spent a lot of money coming up with how can we treat the most water in the smallest space through this soil, and still have it infiltrate the volume that we need to treat to make this effective. So there's a lot of science that goes behind this. We'll talk more about that in a little bit. But the key here is that we're sort of expanding our realm beyond what maybe we've traditionally dealt with in construction inspection. Why is LID important? Let me ask, how many contractors, construction inspectors do we have in the room? Construction management folks? How about designers? Do we have some designers around? Okay, so we got a little bit of everybody. How about regulators? Okay, good. No. I put up old versus new. Again, our traditional scheme of stormwater is it's a problem. It causes flooding. Our goal was to collect rainwater, get it in a pipe, and get it the heck out of here as quick as we could. And we later started to learn how many problems that causes because we're putting more volume of water into our streams, and it causes erosion in the streams, and that water is dirty and hot and all kinds of other things, and it has all these impacts down there. So the new paradigm is, again, we're looking at how can we capture that water at the source, closer to where it falls, and try and incorporate it into the environmental system as it would have in a non-disturbed state where it falls on a forest. And so try and infiltrate it and use it and mimic some of those processes along the way. I say this is regulatory driven because, as many of you probably know, the stormwater MS4 permits in Hawaii now require LID as your first choice for stormwater treatment. It's a given, it's a requirement. The DOD has adopted it for all of their projects. I live now in Seattle and work there. In the city of Seattle, they require LID treatment for 2,000 square feet of disturbed surface. And it's even smaller than the treatment requirement. Even if you're not required to do treatment, you're required to implement LID. So, and so if you expose base course on 10 by 20 from here to that wall, that slice, we would have to put some sort of LID treatment on this area that we're disturbing. So it's not going away. It's here to stay. So it's something we've all got to learn how to use and how to deal with. Now, the good thing about that is I really think it is a better way to deal with the problem. Like I said, in the past, we collected the water, we get it the heck out of here, and it's somebody else's problem. And so what we're trying to do here is address it right up front. And the reality is, as we're getting smarter about this and learning more about it, and the real key, I think, is incorporating it into the whole project from the beginning instead of that, oh, wait, shoot, we've got to do something frantically. Let's throw this added component into our project, even though we don't have money for it, and try and make something happen. So by incorporating it from the beginning, it can often be cost-effective and even cheaper than traditional stormwater management because we end up reducing the amount of pavement we put down, reducing the size and number of conveyance, whether they're ditches, pipes. We eliminate the need often for treatment at the end of the pipe. So there can be benefits not only to the environment but also to the bottom line. And as with most regulations, that's what really makes them work in the end when we can figure out how to do that. And part of that process is incorporating it from beginning to end, but also making sure that it gets built properly when we build it. And that's a lot of what we're going to talk about today. Again, I want to touch briefly on design considerations, and I don't mean this as a poke at anyone here, but the reality is we haven't been doing LID for very long in Hawaii. It's something that's new to all of us, and the designers are new to it, so they're trying to figure out how to do it. We're trying to take techniques that well, that maybe worked on the mainland, that will take techniques and plans that were done on the mainland and built and do them here, but we need to incorporate considerations for Hawaii, and also maybe we don't even, most of them are new enough even on the mainland, we don't really know whether it was an effective treatment process for a 20-year life cycle, say, because they haven't been in the ground that long. So we're all learning as we go. So the designers are learning how to do it. The client, the DOT folks don't know a lot about LID. The regulators are also learning about it, so they're, kind of coming along behind you. I probably should have included on here the contractors, because we haven't built a lot of these things. So we're all learning, and as we work through more of these and we all get better at it, we're going to see the process come together. But there's an important role to be played in construction management here, and in sort of calling out when, hey, wait, we don't have enough information to do what we need to do to build this, and make sure that we get that corrected at the time we build it, not later. I mentioned earlier the late addition to the contract package. This has been a problem with stormwater of all types, LID and traditional stormwater treatment. We have a requirement that it has to be in the project. It gets overlooked, forgotten, maybe not enough attention paid to it up front. We get to the 90% design and somebody finally says, oh, wait, we've got to have stormwater treatment, so we throw something in there so that it's not really an integrated part of the contract package. It's almost like an addendum or an attachment, and it often maybe doesn't connect up well with some of the other work that's being done. And again, this is where I talk about how we can make this whole process more efficient when it's an integrated part of the process. It doesn't have to be an extra cost, an extra pain, an extra effort for us to include. I'm going to talk a little bit more about constructability reviews in a minute, but so I'll skip over that one. But I'll just point out that we've done a number of LID projects with the DOT recently that are sort of standalone specific projects where the entire project is a stormwater treatment system. And those are, I think, easier to manage because that is the focus of the project. But typically, the stormwater treatment is a part of a larger project that has I won't say a more important purpose, but it has an overarching purpose, like widening a road, building a new interchange, building a new subdivision, whatever it might be that we're working on. And the stormwater is only a part of that. And we'll talk about how that impacts construction management more here in a minute. I put constructability review and contractor means and methods here, and this really is a little bit out of order, but this is something important, particularly on a large complex project. I always try and work with clients to get the construction management team on board at least the 90% design, to look at the plans and specs and make sure that what our designers are coming up with is something we can actually build in the field. Because our construction folks are the ones that know what actually happens on the ground. And they can add a lot of value to these projects sometimes. They still do later on, but then it comes through as kind of change orders or a deductive change order or something in the process. So it's something that we can do. And while we may not always incorporate that in our projects here, we can use sort of that mindset of how do we look at things when we get the plans and figure out what we can do to implement them better to help us out. And I bring up contractors' means and methods because obviously we don't want to tell the contractor how to do the job. But for some of this stuff we're going to talk about, we need to educate the contractors on the importance, or we need to, maybe it's holding a hammer over their head to remind them that we don't want to flood our newly constructed LID feature with sediment from the road work that we're doing over here before we actually put it into use, because we plug it up and don't do it. So it may make more sense to build the rain garden after we build the road. So we talked to them some about construction sequencing, and it's, building that partnership where we work with them to make sure we all understand what we're trying to do and how it goes. And again, this is all part of whether it's a constructability review or your pre-construction meeting, but just making sure that everyone, actually I think I've got another slide on this, making sure that everyone there is included and that everyone kind of understands what their role is, what we're trying to do, and how the stormwater system that we're building fits into the overall project. Another example of this, one issue we often find, if we ask the contractor, well, let's wait and not build this rain garden until the end of the project because we don't want to get a lot of construction sediment into the soil there and plug up the soil so we won't be able to infiltrate soil. And so the contractor goes, oh, good, I've got a laydown area over here where I can park my equipment and do all this. And this is a image I took from the University of Missouri and Minnesota Extension worked together on this. But tire pressures, this is not even a big, 1,600 times 4, so we're talking 8,000 pound vehicle, a big tractor. But you can compact soil up to 2 feet below the surface just by driving across it. So if we, even just parking cars there, we're going to end up compacting that soil and either going to end up having to over excavate and come in and backfill more or do more work at the end. So we just, one of the kind of things we have to be aware of as we're doing this. So construction inspection. I want to run through each of the items here and what, the role of the inspector or the construction management team, or in some parts the contractor is, and how we do this effectively for an LID project. I know we all love reading specifications, and it's kind of like reading the HAR 1155 or EPA regulations. It's not a lot of fun, but the reality is, and correct me if I'm wrong, but most of us have learned what our common aggregates are, what kind of soil we want to see for sub-base, and when the truck shows up, you can look at it, and you don't need to go look at the spec. You don't need to send a sample off to the lab. You can tell this is the right material that we always use for building roads. When we get into building these LID features, you've got a whole new suite of materials that probably we're not as commonly dealing with and aren't as familiar with. We're starting to get into landscaping materials and soils. You see this little cutaway here. This top layer is going to be a mulch with a specification of whatever the material needs to be. Big component of that one is actually weed-free, and that it doesn't come in with a lot of things that we're later going to be spending money trying to remove. We get into this bioretention soil. It's going to be a lot of jurisdictions have standard specs for it, but it's going to tend to be a lot of sand, a lot of compost, a lot of organic matter. The real simple test I can give you for it is if you can take the soil and get it a little bit damp and make a ball and it holds together in a ball, it's not what we're looking for. And you see the picture there of some of the type of soil we're talking about. You get into oftentimes another specific soil that you might specify as an underlayer, and even the gravel. We all know what gravel is, but again, for a road subbase, we're looking at angular gravels that we can compact and make a solid surface with, and these tend to be round river gravels. We're looking for things that are going to maintain some void space and allow water to flow through there. So it's a whole new set of materials we haven't worked with, and understanding what the designer specified and what the contractor's bringing you, and is it the right thing? Another common feature, and I try and avoid this, and I push designers to avoid it, but we often see a layer of filter fabric between here, or not on the surface so much, or they'll wrap this in a filter fabric material. And again, we need to make sure, one, that we're specifying the right type material, that's something that's permeable and is going to let the water through. But what can happen with some of these tighter woven geotextiles, you get one dose of fine sediment in there and it will just coat that fabric and blind it. And you've now just you might as well put 6 mil plastic in there. You've completely eliminated the ability for water to pass through there. So if there's going to be some sort of a separation fabric between like different layers of, if you've got a sand and a soil and a coarse rock and a fine rock layer in a feature, if there is something in there, we need to make sure that it's going to be something that's going to let water through freely and it's not going to blind and clog up. Same with your plans and details. Again, you're all used to looking at plans for projects you work on all the time. When we start looking at LID features, some of the gradings and the slopes and the sort of inlet elevations can be critical on how these things function. Maybe the best analogy I can give you, I don't know if we have folks from harbors and airports, but I know in those kind of facilities you have some real strict requirements on slopes because the top pit can't move around on up too steep of a ramp. So you've got real tight grading tolerances on what you're trying to do, and you often have those kind of things so that you're avoiding high water velocities that may cause erosion, or that you're getting the flow you need into a feature to make sure you get the right amount of water in there. So you're going to see things you're not used to, and don't be afraid to ask questions when you do, I guess is the lesson there. When the contractor starts bringing materials, again, you're going to get shop drawings for things you're not used to seeing. You're going to see materials search for different types of soils, gravels that maybe you haven't seen before. How do you make sure that you're getting what was specified? And sometimes maybe questioning is what was specified, what we really want here, something to consider. Erosion and sediment control during construction, or more importantly during establishment. One of the most common problems we have during construction of LID is what I mentioned earlier. We build the LID device and then we get construction sediment from another part of the project, flood in there, and plug up all this nice bioinfiltration soil that we put in there. And really the only way to fix that is to go in and dig the whole thing out and start over and rebuild it. And here you see a couple of examples where they're going to put a bioswale in here, and they've got it graded out and excavated and ready to go, but they're not putting that in yet. The curb inlet that's going to bring the water from the street in here, they've got it blocked with sandbags, so we're not getting a lot of sediment into that soil. This is, you can't really tell from this picture, but that's a permeable concrete sidewalk. And they've got that completely wrapped in fabric, because if we get a bunch of sediment or construction debris or dirt on that, it'll just plug up the pores in that sidewalk, and the extra money we spend on pervious pavement is a complete waste. You'll also see the importance of having controls. You've got a silt fence here to prevent the sediment from the construction from, again, getting into your infiltration feature. It's a little different than a lot of times in the past. If we had a project that had a sediment pond in it, we build that sediment pond first, and we use that as a sediment trap during construction. And then we'll, at the end of the project, we'll convert it from a sediment trap to a stormwater pond. But we try not to do that here, because again, it's not just the volume of this depression that we're looking to save, but it's the permeability of this soil under here to let that water continue to go down. So we want to protect it during construction. So when we get into the actual construction inspections, I talked a little bit about pre-construction review, looking over the plans, understanding them. If there's something you don't know, don't be afraid to ask somebody. Get with the designer, or find someone else on your team, or reach out to the DOT stormwater team. I know we can give assistance with some of these things. At inspections during establishment of erosion and sediment control and grading, again, to make sure we're protecting the features that we're going to build. When we bring the bioremediation soil mix in, and the subgrade, and a lot of these features have, like perforated pipe under drains in them, getting all that in place, we need to do inspections and photograph it before we bury it so we know what was done and that it was done right. And then the actual placement of the bioretention soil mix and grading and pre-planting prep. And then inspections after the planting and mulching. I talked a little bit about the specs for soil and gravel and some of that stuff. You get into a whole nother realm of plants here, and I don't know about you, I'm not a botanist. I don't know how to tell what kind of plant they just brought me in a 4-inch pot that they're going to put in this thing. So, much like if you're doing a project and it had some kind of fancy electrical control equipment, you might need a specialty inspector for that. When it comes to some of this stuff, you may want to say, hey, wait, we need to find somebody that knows are these the right plants we're putting in here. It's important because a lot of these features are designed with different wetness zones. Depending on the slope, there's some areas of the feature that'll stay wetter and some that are going to stay drier. And you put different plants at these different elevations. And all that's critical, that you get the right plants in the right place and that they're the right elevation above the invert of your pipe, because that's what's going to make those plants thrive and live. And then finally, your final inspections when the project's wrapped up. And just a couple of example photos here. Here you see the original excavation, and we've all seen this before, especially if the soil's a little bit wet, and the excavator bucket just kind of smears the side of the hole, and it looks like somebody plastered it over. And no water is going to infiltrate through that smeared surface. So we go back and make sure we scarify, that we scrape that grade first before we come in with the bioretention soil, so that we have an open surface where we can actually get the infiltration. Another example of protection during establishment, you see they've got it fenced off to keep people out of it. Here's another example where they haven't built the bioswales yet, or the bioretention features yet, because they're waiting until they get grass establishment on the new home development. Because if you build this whole thing, it'll look great, but then until the grass grows up there, or while they're building the houses, and you get a big slug of sediment come in there, you could defeat the whole purpose of building the thing. This is an interesting slide, because this is two very similar features along the same road, at pictures taken at about the same time. And the only real difference here is on this one, the site here drains away from the feature, so we're only getting water from the street. So once they finish building the street and put this in, it's functioned fine. But this one has flow coming from the off-site into the bioretention cell. And again, because they didn't have controls there and that site is not yet developed, you got a big slug of sediment in here. This has got to be completely redone. It's the only way it's going to perform as designed. And I lost a slide in here somewhere, but I'm going to mention it right here because I think this is a good point. When we build linear projects like we often do for the DOT, the designer goes out and does some pre-site inspections. They do some test pits and maybe infiltration tests at 1, 2, 3, maybe 4 locations. And then we get a plan set back, and we've got 2 miles of street side improvements that we're going to do, and we're going to put bioswales in 8 different sections along this road. And they're all done on basically the same design calculations, assuming the soils are the same, that the depth to, if there's any bedrock or a change in a lens in a different kind of soil, that they're basically a cookie cutter design of how much water is going to be able to infiltrate in each of these things. We don't get to see that soil down there until we actually get out there and start construction. So you as the contractor, or you as a construction inspector, or as the owner, when you're out during construction, when we excavate this one and we've got nice uniform soil here, and we go down the road 3 blocks and we excavate another one, and we find out there's a distinct line and a different soil gradient there, that's a red flag. We need to stop and look at that. Do we need to revise the design of that cell, or at least be aware that we're probably not going to get as much infiltration there as we thought because there's a clay layer in the bottom? And it doesn't matter how many test borings and test pits we do, it's inevitable that you're going to see changes in the field, and understanding how those are impacting what it is we're trying to build can help all of us do a better job with what we're trying to do. Another example, I was saying no, don't compact anything. The reality is we're trying to build roads, and we got to have a solid surface to build roads on, and we want something that's going to stand up and last. So here's a good example where we're building a bioswale or an infiltration feature right adjacent to the road, and we have to make sure that we have a compacted surface and a compacted side slope that's going to be able to, so we have the prism to hold up the road. We don't want to compromise our road bed for this. The other obvious caveat to this is utilities. And again, the designer is going to always go and try and identify all the utilities. But when we start doing this and we find out that there's utilities we didn't know about down there, we need to stop and put a little thought into, do we really want to infiltrate a bunch of water on top of an old clay segmented sewer lateral, or a gas pipe, or an electrical vault, or what's there. So need to be aware of what we see in the field and how it might impact the project as we move forward. So we get to startup, and I call this startup because that's when we're gonna move the sandbags and put this thing into work, starting to treat stormwater. And when we get to project closeout time, we get to a pre-final inspection. Our typical highway project, we finish up everything, we have a punch list, maybe there's some striping they need to fix, and this curb over here needs to be repaired, a few little things, and we need to get grass establishment over here, and we walk away and we come back a year later to see if the grass grew, and that's kind of the period. And with these, we have almost a different cycle for this startup and O&M and maintenance period. And we often include in the contract that the contractor has to maintain some of these things for a year. Not always, but often. And that inspection and maintenance might be on a different frequency than what the project normally requires. So it can be sort of a different beast, and I'll talk a little bit more about that in a minute, but it's something to be aware of. But we do want to make sure that there's not going to be a source of sediment that's going to come in and plug this up before we pull the sandbags and put it into service. And probably want to do inspections those first couple of times it rains to make sure we're not getting impacts that we did not consider. So again, when we're talking about the startup and the O&M process, we have, not always, but ideally we have an O&M manual that goes along with some of these features. It's often prepared by the designer. If the BMP that we're putting in place is one of these proprietary concrete box, like the Infiltration box or the modular wetlands or some of these others, it's often a cut sheet that came from the manufacturer. And it's important that we provide that local input. If we were actually there when they build the thing, and we noticed 3 times during construction that we built these 6 bioswales, and this one right here just seems like it's getting a lot more water and a lot more sediment, and we keep having problems with it. So even amongst these, what we thought were 6 identical bioswales on this project, we may need to go back and revise that O&M manual and say, hey, the 3rd one here needs to be inspected, every 2 weeks. The rest of them can be inspected quarterly or whatever it is. And some of this will change during the startup period and the contractor maintenance as we see how this goes. But again, when you're actually there building it, you have more input on this, and it's important that we reflect as-built conditions. If we came to one of these bioswales and we realized there were some utilities down there we didn't know about, and we ended up putting a plastic liner under it, make sure that gets into the as-built, but it also may impact the O&M of that device, because maybe we already know we're not getting a lot of infiltration there, so we're not as concerned about it. So it can impact how we operate it in the future. So, take advantage of the local knowledge and the as-built information that we gather as we're working. And again, I come back to the maintenance period. Most of our contractors aren't, I mean, we work hard to get grass to grow, particularly in some parts of the island. It's a struggle sometimes. Getting one of these planters with different kinds of grasses and plants, and it takes a little more maybe special skills to get these things started and established. The contractor may not have the abilities or the interest to do that. He may hire a subcontractor. Do they have the ability and the interest? There may be the need to reach out for some other support. You know, is there someone else that can help to make sure that we're doing this right, so that we get the plants established, we get the thing functioning. It's not uncommon when we do detailed sampling analysis. If we build one of these things, for the first few months that it operates, it may actually be a net exporter of nutrients and sediment, because there's fines in some of the soil, there's fines in the mulch, there may be nutrients in some of that. So sometimes we even use fertilizer, although I try and shy away from it in designs, but we may have some fertilizer in the plant establishment or even the soil that the plants come in. So you can see in that initial phase some export, but we want to get it to where the plants are established and it's performing its job of filtering out some of those pollutants and working there. So again, oh, well, it's good Kelly left the room so I can volunteer. You know, if we do need help, or you have questions about what's going on some of these things, reach out to Kelly and the stormwater team, to Brant. I'm always happy to weigh in. I've got an opinion on everything. I may not be right, but I've always got an opinion. But and Brant can always get a hold of me if you need something. So again, just a couple of pictures talking about project closeout and handover. When we do finish the maintenance period and we're signing off on the project, we're not done because we've got to find somebody to maintain these things. You know, by definition, these features are designed to capture sediment. It's not really a design feature, but what we found is that they're really good at capturing trash, because they tend to be depressed areas and they've got lots of vegetation in them, so the trash blowing down the street blows over here and gets stuck all in the plants. It's great for our trash removal program, but somebody's got to go out there and maintain it. So there's a little more importance placed on the handoff to operation and maintenance of these things than, say, a roadway, which we build a new road, and at least we like to think for probably 5 years it's in pretty good shape and we won't be out there doing a lot of maintenance on it. It's not unusual to see this rain garden at handover turn into this in a short amount of time. It's doing what it's supposed to do. It's capturing that sediment that's no longer being discharged, but we need to get in there and clean it out and maintain it and replace the mulch so it can continue to function the way it's designed to. So there's a little bit of an extra step there to make sure that when we close out the project that we hand it off to someone who's going to continue to maintain it and keep it functioning. So, few, take-home message for you, a few ideas. I say learn what you know and know what you don't know. And don't be afraid to ask questions. There's going to be things that come up in planning, designing, building, doing the construction inspection of LID features that are going to be new to you. It's going to be stuff you haven't seen before. The difficulty comes is some of it may be more important than you realize, like making sure that the soil in the spec is actually the soil that we got at the site. So don't be afraid to ask questions if there's something that doesn't look like what you think it should be. I think there's resources to reach out to ask for the help as we all work together to learn and sort of grow this process of how we select our sites, design our projects, build them, and then turn them over for operation and maintenance so that they continue to function as intended. And I showed you here, I think it's interesting, our Stormwater Permanent Best Management Practice Manual, I think we updated that last year, 2015. But really the manual that we put together in 2008 is primarily focused on LID techniques. There's a number of them in there. And it goes over, it includes a lot of this stuff. So there is some good information out there just within our DOT resources. And there is a ton of stuff on the internet. For this presentation, I borrowed quite a bit of stuff from this Washington StormwaterCenter.org. This is it's a joint effort of Washington State University and another a nonprofit in Washington. And they have tons of training materials. They have all kinds of stuff on LID design. They've got whole things on, like the monitoring and sampling of, the influent, the effluent, and all the stuff I was talking about, like the discharge over time. So you can actually see the pulse of actually there'll be a net exporter of nutrients when they're first built until they get established and settled in, and then how they perform. So there's a lot of good stuff out there. And I believe, Brant, correct me if I'm wrong, but we're going to put these presentations up on the website?
Yep, all presentations will be...
So you don't have to scribble these all down today. You'll get an email when they go up there, and you'll be able to go and find this stuff and look at it and follow up on it from there. But this is just a smattering. If you go on the internet, there's a lot of good stuff out there. There's not a lot on construction management, and I don't think that's really been focused on enough, which is part of why I wanted to have this discussion today and see what people are thinking.